Hi, in this video, let's continue our examples uh, about logarithmic equations. So we have equations that contain terms of the form log x with base b, where b is a positive real number. Remember, um, b is a positive real number wherein b is not equal to 1 are often called logarithmic equations. So before we solve logarithmic equations, let's remember the equivalence, this equivalence. So when you say log of x with base b is equal to y, this is just equivalent when we say x is equal to b raised to y. So as you can notice, y is our exponent and this is our base b, which is equal to x. So let's say, for example, we have logarithm of x with base 5 is equal to 3. This is just equivalent when you say x is equal to 5 raised to 3. Okay, so we will use this equivalent of this, for example, in order for us to solve or to get the value of x on a particular logarithmic equation. So let's take, for example, number 1. We have logarithm of quantity of 2x plus 19 with base 3 is equal to 3. Now, our objective here is actually to get the value of x. So to get the value of x, we will use this equivalence, this equivalence right here. And so we will use this one. So here, this becomes 2x plus 19 is equal to 3, which is this one, the base 3 raised to 3. So when we get the value of x, it's quite easy now. So 3 raised to 3, that is 27. 3 times 3, 9 times 3, 27. So 2x plus 19. So 2x equals 27 minus 19. Just continue. This is equal to 2x equals 8. So we're going to divide to both sides to get the value of x. So x is 4. Okay, let's try to check whether our answer is correct or not. So to do that, again, we are going to we're going to check let x be equal to 4 and use the original equation, that's log of 2, and our value for x is 4, so that becomes 2 times 4 plus 19 over 3, so that's 3. So just simplify. Okay, we have log 3. This one is 8, right? 8 plus 19. Of course, 8 plus 19 is 27. Okay, so that's 27 is to 3. Is it really? So convert this last equation to its equivalent form. So 27 is just equal to 3 raised to 3. Is it? Yes, because 27 is just equal to 3 raised to 3. So indeed they are the same. So which means to say that x equals 4 is really the value of x. Okay? So that's how you solve number 1. It's quite easy. So for number 2, we have log x with base 10 plus log of quantity x minus 3 with base 10 is equal to 1. Now remember, we're going to apply. We have to make sure that this expression on the left should be expressed as a single logarithm before we can apply this property. Before we can apply this property, make sure that the expression here at the left side should be in singular logarithmic expression. So dapat isa, no? So we do that by applying the property that we have learned in our uh, logarithmic functions. So we have some discussions there about the properties of logarithm. If you can still remember, so remember the property that is when you get the logarithm of n with base b plus the logarithm of n with base b, that's equal to the logarithm of b and multiply the expressions. Okay, so you're going to multiply m and n. So we're going to apply this property right here. Okay, so again we have number 2, that is the logarithm of x with base 10 plus the logarithm of the quantity of x minus 3 with base 10 is equal to 1. So what we will do here is we're going to express this one as a single logarithm before we apply the equivalence. So what we'll do here is we're going to combine by using the property, this one. So that becomes log 10. Then this will become x times x minus 3. That's equal to 1. Okay. And then just simplify. So that becomes x squared minus 3x. That's equal to 1. So that's a single quantity. So we will now apply the equivalence since we already express it as a single logarithm. So we will apply this one. Okay. So this becomes now x squared minus 3x is equal to 10 raised to 1. Then just continue. This becomes x squared. So this becomes quadratic equation. So 10 raised to 1 is 10. Then transpose to the other side. That becomes minus 10. And remember, we're going to solve now a quadratic equation. So I think we can use the factoring here. So it's quite easy. So let's apply the factoring. Minus 5x plus 2. Okay, remember we're going to factor this one. Okay, and so just continue. Of course, this one becomes x minus 5 equals 0, or the other one is x plus 2 is equal to 0. So we solve individually. That's x equals 5 or x equals negative 2. So we have two values now for our x. We have our x, which is equal to 5. Okay, x is 5, and x equals negative 2. We can do the checking so that we can verify whether this 5 and negative 2 are really solutions of our original equation, which is log x 10 plus log quantity of x minus 3 with base 10 equals 1. We can try. Okay, so let's try to check. Okay, let's do the checking. Of course, we will try one value. Let's say x equals 5, and then we write the original equation. That's log 10 x plus logarithm of quantity of x minus 3 with base 10 equals to 1. So just simply substitute. Let's see. So that's 5 plus logarithm of 10, 5 minus 3, that's equal to 1. So apply the, of course, simplify first. Log 10 5 plus log 10 2, that's 1. Um, Combine using using a property. So this becomes log, then this becomes 5 times 2. All right, then that's 1. So of course we don't know. So this becomes log 10 with base 10, that's equal to 1. Yes, that's equal to 1. Because, yes, indeed, that's equal to 1. Because this is actually where we are going to apply the property. If you can still remember last time that there is a property, log b of b, that's equal to 1. Because equivalently, this means b raised to 1, which is b, right? So, of course, that's b equals to b. So here, we've already verified that x is indeed a value of our equation, which is this one. So now, that would be for the second example. So you're going to apply the properties of logarithm, and we're going to apply the equivalence, very important, very crucial in our solutions. Okay, so do not forget to, again, apply this. It's very important. Okay, next is number 3. So I'll just copy the given. That's log 3x squared minus 5x plus 2 with base 10, then minus log x plus 2 with base 10 equals to 1. So what we will do here is we're going to combine the left side and then expressing this one as a single logarithm by applying the property. So can you still remember the property? So remember, we will apply this property, logarithm of m with base b minus logarithm of n with base b, that's equal to logarithm of b m over n. So we will apply that one. So the left side now becomes logarithm 10, then we have 3x squared minus 5x plus 2 over x plus 2, which is equal to 1. So we've already expressed it as a single logarithm, so we will apply the equivalent. So that becomes 3x squared minus 5x plus 2 over x plus 2 is equal to 10 raised to 1. Okay. So yeah, we're going to solve this rational equation. So that's 10 multiplied to x plus 2 by using the cross multiply. So this becomes this, and we have 1 multiplied to this expression, so we are left with 3x squared minus 5x plus 2. We're going to solve quadratic equation. So 10x by distributive and then eventually this will become quadratic equation. So 3x squared minus this becomes negative 5x minus 10x plus 2 minus 20. That's equal to 0. Simplify. 3x squared minus 15x minus 18. We can factor this one out before we can solve the quadratic equation to make it simple. And divided by 3. So cancel out. So you're left with x squared minus 5x minus 6 equals 0. 0 divided by 3. And then solve this very simple quadratic equation by factoring. I think we can solve this one by factoring. So we have x and x, negative 6, positive 1, and solve individually. So we have the value now, x equals 6 or x equals negative 1. So we have two values for x equals 6 or x equals negative 1. We can try some values here for x to check. For checking, so we will separate a line here, and then let's do the checking. We can try negative 1. All right, so let x be negative 1. So the original equation is this one. Substitute. That's negative 1, right? Simplify. So we don't know if they're really equal. So we have negative 1 squared, that's 1 times 3 is 3. Positive 5 plus 2 minus log 10, we have 1. Right, we have 1, which is equal to 1. Is it really? So we have logarithm of 10. This is 10, right? This is 10 minus the logarithm 10 raised to 1. Is it equal to 1? We can combine the left side as one logarithmic expression. So this becomes log 10 over 1. Is it equal to 1? Just continue. So log 10 divided by 1 is 10. Is it equal to 1? Yes. Log 10 with base 10 is indeed equal to 1. That's actually a property, if you can still remember. The property is, okay, remember, we have, log b with base b is always equal to 1. So indeed, our answer, the left is equal to the right. And so, we can say that this indeed is a solution of our equation, which is this one. Okay, so I hope you've learned something about how to solve equations. So you're just going to apply the properties of logarithm and apply some definition like this. very important in the solutions for equations involving logarithms. Sometimes you're going to sometimes to solve uh, going back to exponential equations, sometimes you are going to apply ln both sides or logarithm of any base in general both sides so that we can get the x. As you can see, it is usually the unknown is in the exponents. So as you can see, so here it's very simple. If you can express the left and right expressions with the same base, expression of the same base, then you can apply property 7.1, and you've already learned how to apply that one. So that would be all for this video. Thank you very much and have a nice day.